We're going to be looking at integration by partial fractions. Today, we're going to concentrate on case 1 when we have a denominator with unique linear factors. For each linear factor of the form ax plus b in the denominator, there will be a partial fraction given by a, capital A, over ax plus b. And here the capital A will represent a constant. Okay, so let's get started with our first example. We are going to integrate 7 minus x over x squared plus x minus 2. First, note that the derivative of the denominator is 2x plus 1. The numerator is not a multiple of 2x plus 1. So in no way is this a natural logarithm. The first thing we do is check to see if the denominator can be factored. And in this case, it can be. We're looking for a product of -2 and a sum of 1. Okay, so we're going to have as our factors an x plus 2 and x minus 1. So we now take our original fraction with the factored denominator and we express it as the sum of 2 different fractions. And in one fraction, we include the denominator x plus 2, and the other will have a denominator of x minus 1. So the numerators will have single letters on top, just like our formula sheet indicated. We'll put A in one and B in the other. At this point, we imagine moving this to a single fraction. So in other words, we're adding the 2 fractions together. We need this as our common denominator. So this means the numerator would be of this form. The A would have to be multiplied by x minus 1. And then we will have plus B, which would be multiplied by x plus 2. That's how we would add these 2 fractions together. Now, our objective is to work out values of A and of B. Because if we know those values here, each of these integrals is going to be a natural logarithm. How do we find those values? We take the original numerator, which is 7 minus x, and we set it equal to this numerator here. Now we proceed to solve for both A and B by using the roots. What values would make this term and this term equal 0? Substituting x is 1, substituting x is -2. So those are the values we substitute one at a time now. Let's start with substitution of x is 1. On the left side then, we will get 7 minus 1, or 6. On the right side, we would have A times 0 plus B times 1 plus 2, or 3. What does this mean? It means 3b is 6, and therefore the value of b is 2. 6 divided by 3. Next, substitute our second root, which is -2. In the left side, we would then have 7 minus a -2. And that's the same as 7 plus 2, or 9. On the right side, we will have A multiplied by -2 minus 1, or -3, plus B multiplied by 0. This now means that -3 times A is 9, and therefore A is 9 divided by -3. We can now go back to this version, placing A in the numerator of the first fraction and placing B in the numerator of the second fraction. Okay, so I've gone right here back to this form with the two fractions being added together, and I'm simply substituting A is equal to -3 and B is equal to 2. Each of these integrals is now a natural logarithm. Remember the condition for a natural logarithm: the expression in the denominator must have an exponent of 1 only, and there must be in the numerator a multiple of the derivative of each denominator. In both cases, the derivative of x plus 2 and x minus 1 is equal to 1. So we can simply push the coefficients such that they are multipliers out front like this. And then upon integrating, we will have -3 times the ln of x plus 2 plus 2 times the ln of x minus 1. There will be our constant of integration at the end. On the main formula sheet for the unit, I've also included properties of logarithms that will allow us to simplify this answer. We start with the third property here, taking each coefficient, making the coefficient an exponent. Okay? In addition, we can start by putting the first positive term like this. Start with the positive term, then it looks like this. Now we'll use that third property, so this becomes x minus 1 all squared, and after the subtraction, x plus 2 all cubed. Okay, so again, that was making use of this property. Now we'll use this property. If we have the subtraction of two logarithms, it's like writing it as a single logarithm. The argument will be a quotient. And so our final version will look like this. X minus 1 all squared will be on top of x plus 2 all cubed. If you look at your table of integrals, you'll find that we always use absolute value signs here around our argument, and that's of course because the logarithm of a negative number is undefined. Okay, so that is the first example. We'll take a quick pause and go on to solve another one together as well.